This guy. All right. Hi, I'm Clyde Schaefer. Today I'm talking to you about this open source game console that I've created. It is called the GameTank, and it's there's a lot of ways that I think to describe it over the years. At first, I kind of started doing it as a bit because I was just interested in, like, wouldn't it be funny if I like learned electronics by making a game console, and that kind of spiraled into turning it into this open source platform, where everyone kind of like engage with it the way that they want to engage with it. It's sort of bleeding a little bit into like the idea of own your hardware. Like a lot of game consoles is something that you just like you don't really like own it. It's like you bought the Switch, but Nintendo still owns it and can brick it if you decide to load your own software on it. Not here. So before I get ahead of my slides, hi, I'm from. I'm Clyde. Partially weird homeschooled kid from Long Island. I don't. I have a theremin. I'm a theremin poser, literally. I thought the idea of it was cool, and I took this picture for a work anniversary photo to post internally, and it's my sort of. I do pull it out of practice, but I don't have illusions of being a theremin virtuoso anytime soon. I've been working, I graduated college in 2013, immediately, I immediately was going to work in the game industry, and I managed the feat of getting laid off before I even graduated college. So that's sort of my abortive effort to go into game industry. This is why I was a regular software engineer at non-game companies, which I guess they pay better anyway. You get to see your family. So that's just been my track since 2013. I worked at this other company called Meta for a while, and then they let me go, which I was kind of pretty glad about this year. I think it's a little embarrassing to continuously more embarrassing to work there. No shade to anybody I know that's still there. So what is the GameTank before I talk more bad things about my previous employers? So open source game console. It is actually outputting analog video. It uses cartridges. It uses the old 9-pin gamepad ports. And this is because I've seen other sort of open source or DIY game console projects before, and I'm not gonna throw shade on those projects because they're very impressive, works, and they're very good, good projects. To me personally, they weren't that satisfying because it wasn't a console. You would do stuff like everything would be on an SD card on the back of the board, which seems a little weird to me. You'd have like a controller port on the front or controller port on the sides, or like, oh, I made a cartridge, but it's actually a little pin header. None of it was like, it just doesn't feel. If I was to make that project, I would be like proud of myself. I wouldn't feel like I made a game console. Like when I was a kid, I wanted to make a game console. Like the Nintendos and Segas of the world. I also didn't use an FPGA or microcontroller in there or anything. Part of that was because microcontrollers would be boring. I already am a software engineer. I know how to program something that's just going to be like, oh, here's how I do a function that outputs this. Great. I've learned next to nothing. So that's where we are with this. This is something that you can just. What's nice about that, though, is the moment you put all the chips in there, you have a GameTank. There's no need to load an FPGA configuration, flash a microcontroller. It's just sort of, it has an inherent GameTankness when that's all connected together. And I think there's something like really enticing about that, really interesting. I've been asked a lot. I have this bullet point that says it plays GameTank games, and I've been really strongly considering it making one of my slogans because I get asked this a lot. What games does it play? Well, GameTank games. Not NES. Yeah, good games. Not NES games. I mean, it's and that's just because I think the reason that I get asked it a lot is you see a lot of these boxes on the market that are like Raspberry Pi in a box. It plays a bunch of emulators, and that's a valid product. It's very utilitarian. You're not really trying to create like something really new there. It's a utility for playing games that already exist, for engaging in an existing hobby. And this is sort of like itself. It's basically just a game engine in hardware form. more on why I made a console. Just personally, I had a lot of unanswered questions about how these things worked. Things like composite video. Composite video is a weird, magical thing. If you know about, if you're one of those kids that grows up like at least doing something like plugging a battery into a light bulb, you have some concept of circuits, and maybe you have the concept of how audio works, the sound wave. The electrical wave pushes the speaker in and out. More on that later. But video, there's one conductor. How does that work? A video is it's like one of those like cookie rolls, where you cut it and it has the picture in there. That's somehow coming down the tube. Like to someone who's not like already primed to think about these things as being like serial in nature, it's kind of a kind of a mindfuck. And that's what the childhood dreams I alluded to before. Is like I knew I wanted to go big in video games as a kid, and I thought, what bigger way? This child of the console wars here. What way to really matter in video games? It's not you're not just being a studio. You're Sega. You're Nintendo. Microsoft wasn't in the picture yet in game consoles, and I think at the time Sony not really either. So it was just that. So yeah, that was like, that's where you end up. It's like making a game console was the wanting to be an astronaut of wanting to be a game developer. And then I thought it'd be funny is literally just like for the longest time, this is the most accurate way I could describe, put into words my motivations here. I think I actually have found that last bullet point to be pretty well received sometimes. I've had one person say, quote, iconic. So, all right. And of course, I thought it'd be neat. I thought the thing was 6502. I picked it up. I was like, there's something neat about this thing. There's some discovered benefits. I like to separate these motivations into why did I start? Kind of less interesting. Why did I keep going? More interesting. When you have a system like this, everything happens the way that you want it to. It's deterministic. There's no OS to negotiate with, no drivers. You're not going to get preempted by an update. You're not going to be in the middle of a boss fight and all of a sudden the screen goes blue because somebody in Redmond pushed the button to release something and it says, hey, let's pick a time to get you up to date because your system is not up to players' standards. I programmed a little bit for DOS and VGA kind of stuff. This is where I really liked working with a frame buffer for graphics. You can just put stuff into there. You're not really positioning sprites on a screen. But it's kind of slow. If you're just copying bytes into a place and you want to do this at 60 frames a second, anything really advanced, kind of takes time. It takes time to do a screen fill unless you're going raw assembly there. So I had fantasized about hardware features that would speed things up a little bit, give me some parallelism, give me and because it seems like a thing that should exist in the hardware. Why doesn't it on x86? Seems like a mission. I later learned once I got into this more that somebody else had thought the same thing. They made a little computer called the Amiga. Maybe Amiga should have won the computer wars. That would have been nice. And I mean, isn't making a console just a really great bit to come into?
Do it for the bit.
Do it for the bit. Do it for all 8 of the bits. So in this talk, I'm going to explain how the system works. I'm going to sort of tell it intertwined with development milestones, roughly in the order that I created this stuff, and what problems I solved, how did I get there, and what actually is the final system has, and that's sort of how you get what influences these things. A big part of this project is with a fantasy console, which is one that only exists in emulator form, you're creating it kind of for a nostalgia purpose or for a creative limitation purpose. You're doing top-down design. And so you're picking these things like the resolution and the other aspects of it, like the Pico 8, and they're not really corresponding to any kind of physical limitations. I've seen a lot of people ask, what if we made a hardware Pico 8? And that's not really that meaningful of a project, or it's a very ambiguous project. Are you going to make something that plays most Pico 8 games, or all Pico 8 games, and then some, and at which point you've ended up just creating another modern PC, because you've got your Lua interpreter, everything. So this is sort of a bottom-up development where everything is informed by hardware limitations, running into problems of sourcing parts, getting parts that are fast enough, getting parts that play nice together, parts that are feasible for a hobbyist to assemble by hand. And of course, I'm also going to highlight community contributions, many of which are from people standing right in front of me. So, but there's a separate thank you slide for that, so you will wait for your thank yous. And you're going to see some games. So when you start with this, I talk about bottom-up design. You have to think, what's in a console? What do you have to build to end up going this direction? And this is sort of how you end up also stringing together these things from going from I want to learn digital electronic design, starting from I only know how to plug in Arduino modules together, to what are the sequence of projects I need to do together to get something kind of interesting, get what I want. We've got, picture is the obvious one, the biggest has the biggest unanswered questions, it's sort of the most mysterious, and going for like NTSC composite video. Sound a little more straightforward, but still something that you have to sort of like solve. How do you read controllers? What are methods for that? How are you going to store your data, feed data into the system so it's going to run and execute? And finally, what exactly is the backbone that ties all this together? This is going to be, for some in the audience, a bit of a refresher, but for others, maybe, let's get to find out about for the first time, and I try to explain a little about it here. This is all built out of besides the CPU and the RAM chips, it's all very basic digital logic. We're talking about like take your Boolean logic functions and or XORs and turn them into essentially little Lego bricks that you can put on a breadboard and wire them together and make math happen like physically in front of you. And or not, these are referred to as combinational logic. Adders and multiplexers are this as well. This means that their state, whatever their input is, doesn't depend on anything in the past. It's what is combined right now. You're taking two inputs, you're combining them, and you're getting your defined outputs. This is in contrast to sequential logic, counters, latches, shift registers. This is stuff that's going to depend on some past state in order to determine future state. And together, these are sort of like, how do you create computation? How do you create logic? How do you create these decisions that happen and cause other bits to flip in the right places in the right order in response to other bits that are coming in flipping at certain times? You've heard of clock speeds, maybe, talking about computers. Literally what that means is you just have a thing going true, false, true, false, true, false, 1, 0, or 0 to 5, or whatever voltage you're at. 0 to 5 is pretty dated. That's what the GameTank uses. Counters, if you have a thing that's counting up in binary, congratulations, you also have a very handy frequency divider. Your first bit and your next bit as you go up are going to be flipping half as often. So if you have, for instance, say a 28 megahertz main oscillator, and you want to break that down into stuff, 14, 7, 3.5, that's your guy. He's got you handled. You can take that and combine it with some other stuff. You've got your flip-flop. A set reset is basically just it takes a signal, and once it gets a reset, this thing's going to go whoop, and until it gets set, it's going to go whoop, back down. Your counters, you've got that clock rate going, and this is how you basically make any combination of pulse timings that you want. If you want something for certain reasons that has a pulse that is low for 80, and every 470 ticks, it's going to use when it goes back down. That's there you go. It's your horizontal sync. So now we finally get to actually tackling video. This is kind of like the first thing I threw myself at because, it's the thing with the most unfamiliar area. It's where am I going to explore and get new territory. Easy. Black magic. As I would learn, NTSC composite video, a special type of black magic. Does anyone know the secret real meaning for the acronym NTSC?
National Television Standards Committee.
Close. It's never the same color. You are loosely describing your picture and letting human perception. You are right, though. I don't want to use that for giving you the technically correct answer. So, as I mentioned, how is it coming up the signal? Is it like one of those tubes of cookies where you cut it and it has the picture in there and it squeezes out? No, it's like a sweater. It's woven. You have a beam, starts up here, goes all the way down the screen. And this timing, you're going to synchronize your goal in making the signal to synchronize with the timing, so that when the beam is in the place of your picture that's bright, you're setting a higher voltage, and when it's in the part of the picture that's not so bright, a little lower voltage. And this requires some agreement between you and the TV, of course, of what is the synchronization here. Turns out that little signal earlier has a very special purpose that I described, that 470 tick thing. This sync pulse, you're dealing somewhere in the 0 to 1 volt range, and the way that you tell the TV, hey, this is a synchronization moment. You should be putting your beam over on the side here, maybe over in the corner. You just take that voltage right in the floor. That's how it knows. That's sort of special. It's sort of default is kind of kept up here. This is special. This is like you're playing tug of war with your friends. It's like one of those kind of faint things. You're like, you let them think that they're winning for a second. You really give it that hard tug. That's a fake out. This is a tug of war fake out. This is how you communicate here. So, for a specific time, you do this. You're doing this out a very regular period, and then for a specific time here, that's when you do your picture signal. Brighter? Not as brighter. You do that 240 times, there's your picture. Things over here. I learned today that LibreOffice Impress does not respond to an Xbox One controller. If you invert... Huh?
How could they break backwards compatibility like that?
Right? You invert your horizontal sync there, and you don't show any pictures for these lines. Bam! You've got your. This is how you tell your TV, hey, we are starting in the top left corner, and now go down the screen. We're making our picture. So we can make patterns maybe with digital logic, but what we really want to do, image data. And it turns out that we have counters already. So a round chip is just a thing that. It's just a table, just a lookup table, number in, stored data out. So if you're counting your vertical and horizontal position to make those horizontal and video sync pulses, well, just feed those babies right into your ROM, got your pixels, get your picture voltage. For example, up here before your picture, we're going to have a few blanks. We're scanning down. For an example of here, dark, light, medium, dark, 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 light, medium, dark. And there's our... And that's how you get... This is a cat, right? This is recognizable as a cat. Man, shading is hard. Props to real artists. It's hypothetically my cat. But I feel like we're missing something. We're missing some critical component here.
Color.
This is the first prototype of a video output circuit. I found a lovely document. I forgot to actually put a slide about called it's called Lawn Tennis. It's a PDF. It's a very thorough walkthrough of Pong. Pong, as it turns out, does not use any CPU or program. Pong is all implemented in 74HC logic. It's all counters. It's all logic. The way the ball is on the screen, that's just literally taking the right combination of positions and turning on for those periods of time. This was basically me saying, okay, I've got pulses. Immediately stopped reading the document. I've got my sync pulses, I've got my counters, I have a pretty good idea of what to try next. ROM here, this is actually taking a shift register and feeding each of the bits in that. So this is a 1 bit per pixel image. About 256 by 256. Spatially higher resolution than the GameTank turned out to be. But you can see we've only got two colors, or like a little sacrifice there. And I don't have a picture. I decided not to fit a picture of it here. But the back of the board, that screen print, you can tell it really tells you when I did this project. So to recap, brightness is voltage, color is another 3D quantity we are somehow imposing onto this signal. So, in 1950, I couldn't bother to remember the last digit. They decided they wanted to add color to their broadcast and create color TVs. Well, in a weird consumer friendliness that was like uncharacteristic of American industry, they did not want to. They wanted to let people keep their black and white TVs for a while, like until they were able to buy a color TV. It's a pretty big investment. I guess no one's gonna. Everyone's like, oh, I have to meet. Like, they're not gonna get people adopting color broadcasts if there's a separate service for it. So they needed something that could actually piggyback on the same signal and still look fine on black and white TVs without breaking anything, and still also take everything you needed onto these newfangled color sets. So what they came to was adding this color carrier, and this is at a higher frequency that a black and white TV is just going to have left out as noise, which is sort of a handy assumption they could make based on, our older TVs are going to have to do more filtering because our broadcasts are more noisy. Broadcasts get a little less noisy. New sets don't have to do as much filtering, and they can use that data bandwidth for stuff. So that's what we've got here. There's in fact, 3.5 megahertz is an approximation. If you want to get technical, 315 over 88 megahertz is what you type in to get that with. This is why when I'm looking for oscillators, I'm typing in like 28.636363. Well, they don't let you put a bar over it on DigiKey when you're searching. You have to just like take the nearest thing they have in their categories. So how does this carry color? I had to learn about this little thing called phase. Which is dangerously close to having to do, like calculus math stuff, and we're gonna see how close I got to this without having to really like do some kind of integral. If you have a wave move forward or a bit more, that's what your phase is. You've got a reference signal, and you're comparing it to another signal. You're saying, all right, this one is 45 or 100 or 75 or whatever degrees out of phase with the base signal. So that means you have to have a reference signal that's agreed upon with some kind of timing. You're not just going to like have a global thing. It's not like the TV turned on at a random time and your broadcast station over here turned on at a random time. We're going to be in phase to start with. So, maybe you're going to send out video signals and everyone's going to be green. They have a thing for that, and it's called the color burst. Right before the cool zone, and right after the ground slam, so a little bit between there, is they throw in this little thing, this little bit of color, and this is going to establish your base phase. Off the top of my head, I think yellow is the color you would get if you were showing something that's in phase with this, and samples that, and it's actually per scan line. So if you do different ones on different scan lines, you could sort of like get a weird thing going on. It's another thing you have to like do properly if you want proper color rendering. Shift registers are back again. I spent a lot of time trying to figure out, man, analog electronics. I'm still in the digital. This entire project, I've been in the digital domain of design here. Now I have to learn some of the hard stuff. There's no way I don't have to. You can do this in the digital realm entirely. If you have a shift register that's getting 8 times your base signal as its clock, you're essentially creating a digital delay line. You just need to be sure that you have exactly 8 times your frequency. So I don't need an oscillator for my system that's 3.5 megahertz. I need that 28.636363636363 that I alluded to earlier. And this is going to get your selectable phases. So after that, here's my my breadboard prototype for color video. Something that I noticed when I was researching this was that pretty much everybody generating, like I could find on YouTube, that was generating composite video was using like a CPLD or something, or using a GAL or an FPGA or something. Is this something that might have been considered not worth doing in 74HC logic, like purely? And I'm just like, I mean, I was actually, it turns out that I was just not finding Don Lancaster's TV typewriter cookbook, where he basically ends up saying the same thing. I think this is sort of a product of doing this at a time where most of these were on forums where people were talking amongst themselves and not broadcasting it as much. Sort of like I was doing. I was sort of also siloed on here, trying to get unsiloed and producing this. This is the full color range of the GameTank. This is a breadboard that I would take back and forth between my apartment and Hack Manhattan, and have to do a lot of debugging on it just from the transport damage every single time. But I did eventually, get this working, get my ROM chip on here again. There are 200 unique colors, and this is because when saturation is 0, those hue bits aren't really relevant anymore, are they? So that was basically like, and this black and white video took like a couple weeks. This whole summer, that was like a 3-month thing. A lot of people talking about it in the forums where they would say part of the story, and then the rest would be assumed. Because like everyone in that community, they know what you're talking about, and this would be like a forum post from 2007 by people who aren't even like active anymore. Web pages by some long dead radio engineer. So sounds. This is going to be easy, right? You just push the speaker in and out with your voltage. Shift registers come back again. This time you can use them to make noise. Turns out that feeding that in with some XOR gates makes a pretty convincing so you can modulate. Where am I with respect to how? Okay, yeah, actually, I'm making a pretty good case. So this is going to form the basis of the sound system. You take this, you make a couple of square waves. You've got a sound card, and there you go. Bish bash. We've got I just made two dual copy paste, 2 square waves OFSR, and I found these neat little dual ported RAMs where you can just put stuff in on one side, and there's no arbitration to do. This is surely going to be a really great foundation to build the whole house on. And at this time, I was just going to use it as dual ported RAM. I had on this prototype, what I did was I made it so that when you hit specifically 0 into a byte, it would jump back the counter, so you could put multiple sound effects in there. And the way you'd pick a sound effect was by setting your start address, and it would just go and loop that and get whatever sample you want. I was able to fit in a just barely recognizable the sound clip from Super Smash Bros. Melee when you use Fox's reflector, but downsampled, did fit on there, 4 kilobytes, recognizable. To mix all these channels together, there's this other handy component called a digital potentiometer, and this was taking 3 bits of input to pick a resistance, and I built an analog mixer network based off of that. Handy for a mixing stage. You can take existing schematics for analog mixing and then build around that. So, has anybody gotten a subject line in an email that was this before? 2020, supply chains were having some issues, some of them just in complete upheaval. And then that was a good time for a lot of manufacturers to decide, wait, this part, nobody's buying these. We don't need to make these anymore. So, gotta rethink the audio circuit. I still have this one floating around, and as a one-off, it's fun. But we're trying to aim for some reproducibility here. This is the difference between something that has a couple of programs where I waste its potential, not really getting the most out of it on my workbench before moving on to something else, versus trying to attract other developers and see who can do stuff like get C++ to run a 3D renderer on it, or get Rust to compile for it. Stuff that I wouldn't think of by myself. So I needed to change my plan here. So there's two choices: is to try to replace that digital potentiometer in the analog mix, or just come up with something where that's not even a question anymore. But I do still want to use those dual-ported RAMs because you have to buy a minimum quantity, and I thought, man, I've got these sitting around. Okay, so an entire 6502 subcomputer. This one is just focused on making sounds. You put your program onto the 4 kilobytes of RAM, and we've got a hardware timer that's going to give this interrupts every time you want to do a new sample. A double buffered DAC is going to make it so that you do not have jitter. It's going to, every time the interrupt comes in, it will send the buffer out to the real DAC, and then start your interrupt again. So your program has a lot of flexibility. It's all in RAM, so you can do self-modifying code, which is how I went from doing just square waves to FM synthesis. And just get you can get a lot of decent sound out of something that's an 8-bit per sample 14 kilohertz. You can actually adjust that 14 kilohertz. You get 1,024 cycles per sample at 14 kilohertz, and then it goes downhill from there as you make your timer go by faster. But if you really want more samples per second, that's your way. Controllers, actually easy. Unlike sound, which we thought was going to be easy, controllers is very easy, especially if you copy an existing design like the Sega Genesis controller. You've got 9 pins on these typical controller ports, which are very easy to use because you can still buy those. They just sell 9-pin D sub ports, and they probably still be selling them for quite. I'm going to change myself saying this. Quite a long time. I think we're still using those in industry. They're still on CNC machines, so hopefully that's not going to get the DigiKey part status, or at least not an irreplaceable one. On here, I used mechanical keyboard switches for the very first controllers. Red because Cherry MX Red. That's gaming keyboards. Everyone knows that. And you've got a lot of it's a good, relatively inexpensive way to have a switch that you can put on there, and it's going to last like 10 million plus cycles. They're made for that. They actually have ratings for that. A lot of switches you buy, they don't even bother to tell you a rating for the number of cycles, because you look at it, it's like you have a 10,000. This is a button that's going to be pushed once in a while for a thermostat. You want something that's meant to be button mashed. And then the controllers themselves are these. Ergonomic design is hard, turns out. a couple of hot dogs and a SNES controller. Easier to print if you don't put those hot dog arms on there. And turns out when you print plastic and it's got those layer lines, and it's next to other plastic that has those layer lines, and they make a little. That's a lot of friction, which is very bad when playing games. So I would spend 10 minutes per button sanding them down. But I did actually have one big improvement as well, which is multi-material printing. Let me put a nice, very clear button label on here. What I did for the friction problem was that I left a space on the button prints for these acrylic bushings that would slide onto the clip in, and only break some of the time when stretched by pushing them on there. And they would slide very nicely on 3D printed plastic on PTG, which I have used ever since the first time I showed somebody a PLA printed prototype and they accidentally blew it into a million pieces. So, controller V3, because controller V2 almost burned down my house. Acrylic, flammable, lots of little acrylic bushings next to each other, creating a lot of acrylic vapor. flammable. I let a job to go print 100 of these bushings. I go to the other room to get a glass of water. What's that? Oh, that's a run downstairs. Little like fire cube, like right out of Minecraft, on top of coming out of my laser cutter, reaching threateningly up towards the wooden ceiling in the basement, which is connected to the flammable, which is flammable and connected to other flammable parts of the rest of my house where my girlfriend and my cat live. Very bad. I spin around and run to go grab the nearest fire extinguisher, which is the highest safety standards, of course, conveniently behind some boxes out in the garage. I did make it in time. And later, when a friend came over and he saw that I had a fire extinguisher mounted on the wall in my basement, he looked at it and goes, "Oh, something happened here." I'm like, yeah. So other improvements to this is I replaced those bushings entirely. I widened up the holes, and I use what's called a flexure. This is when you have all the buttons are part of one piece of plastic that has some parts designed to bend, and that's going to hold them laterally in place without having to scrape them against the sides. This is going to start using surface mount components, and a pick-and-place machine is much better at putting little tactile switches, which I found a high lifetime, low actuation version of, which is good for game controllers, and that's. But they're much better at those than putting in mechanical keyboard switches. So logic, we've actually, done all the peripherals, right? I look at a 6502, I go, man, this is great. Put that down, come back like a year later. We've got video, we've got audio, we've got controllers, and we've even got. Did I put the cartridge thing? I didn't put the cartridge. We've got controllers. I'll get the data part, which is in the outline. It kind of makes sense, in retrospect, that you could start a 6502 computer project by building all your peripherals that kind of define how stuff's going to interact, and then only finally do you try to unite these things together with a processor. A processor is like a CPU, right? Making a CPU is something that has a lot of mystique to it. And I think it doesn't deserve all the mystique that it gets, because literally all it is a way to sequence these operations between a bunch of shared components, RAM and video output and other memory. It's literally just a guy that's like, hey, address 2008, and another thing goes like here, and then send some data onto a shared bus. You just have some, it's literally all just a bunch of stuff holding the same wire and agreeing on who's going to activate what wire when. And a CPU is just a thing for taking instructions that are also fetched from the data, so it gets that, and it gets an opcode, and that's going to say, hey, so this wants me to check this memory location and make a decision based off of that, and that decision is going to be just another cycle of calling on somebody else in the class. So I went with WDC's 65CO2. It's a W65CO2S. And there's a lot of advantages to using this. Of course, they make it. You can buy these. You can just go on Mouser and get as many as you want. They've added some opcodes in the history of this chip. One really nice one. I don't think it was added specifically by. It might have been added by them specifically. It's called WAI, or wait for interrupt. When you want to set an interrupt going and you have to wait for it to go, and you go into a loop, did I have the interrupt yet? Have some flaggers, have something that checks that. You might have some not necessarily deterministic latency on when is that going to actually, what is the gap between interrupt and continuing. Wait for interrupt literally just puts the whole CPU into a sleep state, and as soon as the interrupt comes in, it just wakes up and gets right back into action. Very good for games, it turns out. One problem with the thing I talked about before with this video is that my plan had been to use a frame buffer, have my video circuit, and the video circuit is going to put bytes into memory and represent colors that way, and there's just going to be a whole bunch of pixels, and you want to draw your character on the screen, you're going to have to copy some pixels, buddy. And copying pixels, these loops, it's not just a copy, right? You're doing your loop, you're like, oh, start the loop, check if the loop is done, pick up, put down. If you're dealing with a couple dozen cycles per byte, you start to wonder if there's a better way to do that. And I talked about that before with the CVGA stuff. So it would be nice to make something like that, wouldn't it? Something that was still reasonable to construct, handle some features that we wished we had easier access to before when doing low-level programming, transparency, parallelism, maybe not an ALU because if you're going to do multi-way directions on this bus, it's easier to you can have a lot of shit. It's a little easier if you're doing this single direction. So I made a blitter, and this is why I referenced the Amiga. The Amiga has one. The Atari Lynx has one. I sure did learn a lot about systems that had blitter after I already implemented sort of backed my way into making a blitter by accident. And this literally is just more counters, our old friends counters and multiplexers again, and you're just going to have that clock through your RAM, and you're just connected to it. It's just like, all right, next. You're getting single cycle copies per pixel. So it's going to be blazing fast comparatively. We're still running at 3.5 megahertz. But at our screen size, that's like 3 times the screen every single frame. Cartridges. I feel like I should have put this earlier, but this is just essentially starts out an EEPROM chip broken out to some pins. And the ones you're going to get that are mostly available are little 8K chips, and you can they're pretty easy to write to. In fact, that's sort of like the first thing I did when studying all this was that I saw the Banner video where it just literally shows, okay, you put your EEPROM onto the breadboard. You plug 5 volts into here, congratulations, you just stored a few, like a byte into there. You can count your way up. I have an idea in my head, a very devilish idea, but I think I might need to wait until I have a bigger community with more investment before I do something like, say, a game jam where I get everyone locked into a classroom with a bunch of books that are references on 6502 instruction sets, some 9-volt batteries, and some EEPROMs. I feel like that's the kind of thing you can only really inflict on college students. Like, college students will tolerate that. People with jobs and a life like adults might be harder to pass that on.
Yeah, that's fun.
All right, great. We'll start right now. A little harder to write to is a flash chip. I actually had to print out a spiral-bound version of the data sheet for this flash chip to to fully understand it. Like, I just made this my bedtime reading. Like, I just, they're at FedEx or Kinko's, wondering what the hell this guy's doing with his spiral printed chip book. But the real problem is the fact that this is 2 megabytes, and the console can only see 32 kilobytes in the cartridge slot at once. So we have this little thing called banking, where these pins that I set aside on the cartridge port are essentially GPIO pins. You can do whatever you want. I've labeled them as SPI pins, and that's sort of what I'm using them here. But I put another shift register in the cartridge, and this is going to handle those extra address bits that aren't being handled by the cartridge port. And because you want to be able to boot consistently every time, the upper half of that cartridge memory is going to be fixed. This is what I call the fixed window, sliding window, or movable window. I feel like sliding window would imply that you could put it at any offset. It's 16, so you've got 16 kilobytes of always available, and then 16 kilobytes chunks you can bank in by shifting out the bits of your 7 high address bits, or it could be 8 if I made another cartridge that had 4 by putting 2 more expensive cartridge with bigger stuff. That's kind of the point, right? It's making this expandable, giving the ability to improve on the hardware even after you've already put it out to several people's gaming setups. Here's some pictures of the cartridge. My current version of the flasher is essentially a stripped down Arduino Mega, but using the newer version of AVR chip, because the Mega 2560, 2650, that's like a $14 chip, turns out. AVR DA64, some jumble of that. That's a $2 chip, much better, same amount of GPIOs, and you're good, you're just 5 volts, you're golden. little programming header, USB-C. We're not messing around with the USB micros that are on Arduino clones, or some of them USB mini if you found really old stock. Nice little custom shell on here, very important notch so that when you put this in backwards, it does not seat and cause any kind of short. And a gap here so that you can fold the label over and it's not going to peel because of the very small surface area on the top of the cartridge. Prototype 1. This is the one that I spent the most time on actually with prototyping at Hack Manhattan, the hackerspace in Manhattan. Great place. I think a lot of people here already know that though. I thought it'd be cool to make something that was prototyped kind of like a PC motherboard. We've got our backplane, we've got our motherboard here, stuff vertically goes in. You might start to see though a little worrisome that this is held together by a rubber band back here. Every time I would get on my electric scooter and put this in my backpack in a box and then spend like an hour just rebuilding the problems that happened like that breadboard prototype earlier. And I think I had a zip socket for the cartridge. And there's that old sound prototype. And then here is a screenshot from Cubicle Night, the first GameTank game. And something you'll notice is that there's a black dot pattern. And this is a glitch that happened with that blitter. One thing that has to happen with a blitter, when you're doing this stuff with memory-to-memory copying, you have counters going, you need a lot of synchronicity there. You need to make sure that you're changing row at the correct time. You're doing the correct number of cycles. And let's say, for instance, you use a chip that was so convenient, the 40103, which is a down counter that you can just set to a number and count down and gives a signal when it's done, and that will let you make arbitrary numbers of counts with fewer chip count. And say that chip turns out to have way more propagation delay than you had assumed, than anything else really in its family. You start to run into stuff like this, where it actually takes long enough for your row counter to report that you are done, that you actually do a whole other pixel of copy before it cuts off the blip. So it's not like it's doing not a full row plus one. It's literally just taking an entire pixel clock to know, hey, we're done copying, making every blip kind of shaped like upside down missing node. Ultimately, the answer to this, and you can sort of see up here, I had a header that was different. You could connect to the clock. You could change the clock speed of this first prototype by plugging it together differently. And some of these clock speeds weren't really viable because of propagation delays. What I ended up sort of doing was, this was actually when the blitter was running at 14 megahertz. I brought the blitter down to 3.5 megahertz, which, fewer pixel copies we can do for frame, but that problem just went away. We have, we can do whole full screens without these weird block pattern artifacts. So I finished making Cubicle Night. I had hoped that I could make the first GameTank game before I made the emulator. It took like 5 minutes to flash that EEPROM cartridge every single time, so that kind of became infeasible. It actually was quicker to write the emulator and then test the game that way than probably all the combined flashing I would have had to do to test every single iteration. I was using an 8 kilobyte EEPROM, and I know that this is an almost exactly 8 kilobyte game because something that's kind of taken for granted in a platformer game is when you hold down the button, you jump once. In Cubicle Night, when you hold down the jump button, you're jumping every single time you hit the ground. And that's because in order to make room for the logic for the enemy I was putting in, I had to delete the code that checks if you're still holding the jump button, if this is a held jump or a repeat. And I said, you know what, this is just going to be one of those games where you can do that. I'm making a room, I'm adding this thing in here, and I need that. Sorry, you're going. And that got me down to pretty much 8194 bytes or something, real tight there. Prototype 2, a big problem with Prototype 1 is because everything's parallel. It turns out you can't actually access the probe points because they're blocked by all the other cards. So this is sort of inspired by something at work because what actually happened in parallel while I was working at what's it called? It was called Facebook then. I had mused aloud to a friend who had also worked there, like, man, I really like doing stuff like working with microcontrollers and chip data sheets, and I wish this was my job instead of this boring web backend stuff that I was doing. And he's like, actually, I heard that, because he was like several floors up from me, but there was like another thing brewing up there. He's like, I've heard they're over at this other table. They're talking about this stuff. They're talking about microcontrollers, and they're talking about display technologies, and you should probably just go up to this guy and introduce yourself. And I kind of had a lucky break there because there was a display I was looking at on Adafruit, the chip controller, the ILI 943 or something, and it's a good thing I remember that then. I don't remember it now, but I had just been looking at it when I got there. This guy had it on his desk, and I was kind of like, oh, it's the ILM 943, and they're just like, you knew that on site. Get this guy a transfer like immediately. And that was like sort of probably the peak of my time there. That was like a time where you're like, really good to be working in a place where you feel like you're enmeshed with the people that you're working with, and your manager like understands you. So that's why everything kind of went downhill after my manager left to go do some quantum computing stuff at some other company. And you get the people they bring in, like the old school like Oracle manager type people that are just like, why are you not writing reports? And I'm just like, so there goes my ratings after that. But I did learn some good lessons. Turns out it's very good to have boards that are highly horizontal, much wider than your product's going to be. Those little mezzanine connectors where you can say like, hey, this is how a board snap together. They're not pin headers that are going to get bent every single time you pull them out. And you can just, it takes up the whole desk, but there's your console. Prototype 3 starts to finally look like a game console. This is the shell, actually. It's this one right here, and I can, show this off later if anyone hasn't seen it. We got the thing open so you can see all the guts. 3D printing case. One final thing I did as an actual hardware change, besides reshaping it into a console, was I added a bunch more of the RAM that is used as the source for the splitter. Because I want there to be potentially a fighting game with lots of frames on there. This turns out that I haven't made a fighting game. The fighting game is a very hard design challenge. You're making something competitive. Everything has this interplay. You really want to, there's a lot to think about there. But you also do want to be able to have lots of frames of animation. Before this, there was only the screen size times 2 for animation frame space. Now there is screen size times 32. So you've got oodles and oodles of sprite space you can decompress into from the cartridge, and it sort of makes up for the low resolution we're working with here, which is like 128 by 128. Is that you don't have a lot of spatial resolution, but you have a lot of temporal resolution. Finally, we have the surface mount version because people kept asking about pre-builts. They said, this looks cool. I do actually earnestly want to engage with this, but do I have to do a $300 part order and spend an entire week soldering it? And I said, fair. Would take some research, would take a while. I got inspired to show at the Long Island Retro Gaming Expo after going there one year, and I had decided that the next year I would do that, and that sort of gave me a deadline to create a surface mount distributable version. And it's basically just every single chip swapped out to the surface mount version. Took the time also, this is also an opportunity to switch from EagleCAD to, how do I pretend?
5 minutes of closing remarks. Technically, you're 5 minutes over.
All right, speed run time, back with long jumps. Ribbon cables, much more sturdy than those mezzanine connectors in production. You don't want to have to keep opening up and reseating. Development tools, we've got a CC65-based SDK. Got linker configs. You can kind of get started on this immediately. I just pushed a thing that that installs the prereqs for you when you download the repo. Bitmap conversion and MIDI conversion are handled by the SDK. So you've got your assets. You just drop those into a folder. Slides will be online. You can see more about this. This is also in the wiki documentation. Getting the important parts in. Here are some screenshots of our emulator and development tools. You can view that VRAM at any time. I've even done a very, very modern thing, which is a thing that will tell you all of the time you spend in every single function, which is something you'd expect more than in like Google Chrome web tools than like, say, a and 8-bit emulator. More tools. Other cool feature: if you have animation tags on your frames in ASprite, will generate macros. Get all this stuff by name. Community involvement. Finally, that's an important thank yous. So I hadn't assumed, I was sort of procrastinating on starting like an online forum or online community for a while, and I forget even how I was talking to this person, in what sort of like venue, but there was this like random internet teenager that said like, you know what you need, and he's made a Discord, and then he made me the owner of the Discord, and he's like, you need to get started on he's like, I'll go find people for you. And sadly, eventually, I'm no longer able to contact this guy because he had deleted. He said something about getting in trouble with his parents that had to delete his account, so he's just kind of like gone. And everyone I've also asked also does not remember his handle. I go back, and this is something that's really true about when people say that like Discord is not archival, Discord is not documentation. You go back after someone's deleted their account, it just says deleted user, so you're not going to even be able to like call them out, thank them. So if you see this somehow, thank you. You helped start something that like really kind of spiraled. We've got a Rust SDK and an emulator, like a second set of tools from DW Bright, who's sitting there. We've got a sound effect editor created by Nick. We've got Hannah, who does the cartridge art for Cursed Fiend and Ganymede.
It's an important hit scan on the projector, I'm sorry.
Oh, that looks way better on my laptop. I'm so sorry, Hannah. that is oof. And Cyril, who's over in Seattle now. I was at my PAX West booth, really busy, and the deadline for the CFP was coming up, and he's just like, "You want me to just like write your abstract for you?" And it's yeah, that's how I'm standing here now, because Cyril actually typed up an abstract, and it's like, this is like the thing with the Discord. Just someone comes along and just like, okay, you're doing the thing here, but you really need to give me a boot and get me going. So we've got games. Here's ones I've made. Here's ones that more people have made. And then here's one that this guy in Japan made after buying my console, not elaborating, not really communicating me any further than that. Did not buy a cartridge flasher. Didn't buy a blank cartridge. I actually threw one in because I just thought it was a mistake that he didn't buy any games. And I just couldn't. And then a year later, all of a sudden, he starts posting these games. He has like 20 games now that he's been porting to every 8-bit he can find on the planet. I don't think he's done anything for Commander X16 yet, but he's just decided the GameTank is in the list. So he actually is like, you go on GameTank.zone/games. He literally half the list is Inafuto's titles, which are actually like pretty entertaining. So developer shout-outs, just these are people who have done development on stuff, gotten stuff to build on the GameTank, or anything from dogfooding the SDK to publishing games. I'm gonna do the next slide. They're all on the thing. How to get involved? You can make games. You download the SDK. As I said, I've added a thing that even installs most of the prerequisites for you. Node.js. I'm leaving you and your package manager to figure that out. You can get involved if you're a hardware guy by making hardware guy or gal or other making add-on hardware. We have a big expansion port on the back of this. That's a 26-pin D-sub that exposes a bunch of stuff. Next plans: continue growing the community, make more game tanks. I'm definitely get this part in. Partnering with Craft Supply. We're trying to do a pre-order campaign to make a whole bunch of game tanks, probably in Croatia. And do them, and I make these like 10 at a time in my basement right now, and I'm trying to and also my last big batch was in December. I'm having tariff problems. These are I used to get them on 0% tariffs because game console, that was actually a thing, and now my last order of any hardware at all was a $400 order that was $200 in tariffs added on, so $600 total order. Did we cut it off?
I gotta get to the.
All right.
There's a game jam right now.
There's a game jam. The theme is incremental or clicker games. Go to the Discord and you can find out more about the game jam. Thank you so much for coming to the talk and everybody watching online.